He walked into the Tesla Gigafactory, wearing steel-toed boots that had seen 40 manufacturing floors, carrying a thermos of coffee his late wife had given him 23 years ago, and holding engineering drawings on actual paper because he'd learned decades ago that batteries die but blueprints don't. The production manager, a 29-year-old wearing a move vest and break things, Hoodie looked at him and actually laughed. "Dude, are those paper drawings? What is this, 1987? His team of engineers, none older than 32, snickered. One of them whispered loud enough for everyone to hear, "Why did they send us a grandpa? We need someone who actually understands modern manufacturing." Robert Kaczynski, 67 years old, looked at the frozen production line that had cost Tesla $47 million in the past 72 hours and said quietly, "I'll have this running in 3 hours. But first, someone needs to show me which one of you children broke it." The room went silent. The production manager's smile disappeared, and when Robert walked over to the main assembly robot and pointed at a single miscalibrated servo motor that 8 genius engineers had missed for 3 days straight, someone in the back whispered, "Holy shit." Robert Kaczynski was 67 years old, and he was standing in a Walmart parking lot in Sparks, Nevada, eating a $4.97 rotisserie chicken straight from the container because his apartment didn't have a working stove and he couldn't afford to fix it. This was not how he'd imagined his life would be at 60. He'd worked in automotive manufacturing for 44 years. Started as a junior technician at Ford in Dearborn, Michigan in 1981, when he was 23 years old and fresh out of a technical college with more enthusiasm than sense. Worked his way up through every level of manufacturing engineering, robotics, quality control, production management. He'd been part of the teams that launched the Ford Taurus, the F-150 redesign, the Explorer. He'd managed production lines that built thousands of vehicles a day. He'd solved problems that everyone said were unsolvable. And then, 3 years ago, Ford had decided he was too old. They hadn't said it that way, of course. They'd used different words: restructuring, early retirement incentive, making space for fresh talent. But Robert had been around long enough to know what it meant. "We're replacing you with someone half your age who costs half your salary and won't question our decisions because they don't know enough to see the problems coming." He'd taken the early retirement package, $180,000 severance, continuation of health insurance for 18 months, and a pat on the back for his decades of dedicated service. It had seemed like enough money at the time. He'd find another job. He'd thought he had 4 decades of expertise. Companies would be fighting over him. They weren't. He'd applied to 317 automotive engineering positions in the past 3 years. He'd gotten 23 interviews. He'd received 0 offers. Overqualified. Looking for someone who can grow with the company. Cultural fit concerns. "We need someone with more current experience." Translation: "You're too old. You cost too much. You'll be dead soon, so why invest in training you?" The severance money had run out 14 months ago. His retirement accounts, which he'd been forced to tap into early, were down to $43,000. His health insurance, which he now paid for through Cobra, cost $1,247 a month. His rent on a studio apartment in Sparkside, moved from Michigan because Nevada had lower costs of living, was $975 a month. He was surviving on approximately $1,400 a month from Social Security, which didn't cover his rent and insurance, let alone food, utilities, and the medication he needed for his blood pressure and cholesterol. So, Eddie, he was in a Walmart parking lot, eating a rotisserie chicken in his 2008 Dodge Ram that had 247,000 miles on it and made concerning noises whenever he went over 40 miles per hour. This was retirement. This was the reward for 44 years of work. His phone rang. Unknown number. He almost didn't answer. Probably a scam call. Someone trying to sell him extended warranty or tell him his social security number had been compromised. But he answered anyway because unemployed people answer every call, just in case. Hello? Is this Robert Kaczynski? A young man's voice, stressed, talking fast. This is Robert. Mr. Kaczynski, my name is Tyler Chun. I'm a production manager at the Tesla Gigafactory in Sparks. We got your name from a referral through the Nevada Manufacturing Alliance. We have an emergency situation, and we need someone with your background. Are you available for immediate consultation work? Robert set down his chicken. What kind of emergency? Our Model Y production line has been down for 72 hours. We're losing approximately $650,000 per hour. We've had our entire engineering team working around the clock, and we can't figure out what's wrong. We need someone with deep automotive manufacturing experience who can come in and troubleshoot. Can you be here in 30 minutes? $650,000 per hour. For 72 hours. Robert did the math automatically. Over $47 million in losses. What's the pay? He asked. $400 an hour, minimum 4-hour commitment. If you can fix it, we'll discuss longer-term arrangements. $400 an hour. That was more than Robert had made at the peak of his career at Ford. I'll be there in 20 minutes, he said. The Tesla Gigafactory loomed out of the Nevada desert like a spaceship that had crash-landed in the middle of nowhere. Over 3 million square feet of production space, one of the largest buildings in the world by footprint. Robert had driven past it hundreds of times over the past 2 years, watching it grow, watching Tesla vehicles come off the production lines and transform the automotive industry. He'd applied to work there 6 times, never heard back once. Now they were calling him because they were desperate. Robert parked his battered Dodge Ram in the visitor lot, grabbed his thermostat, one Margaret had given him before. The cancer took her in, his leather portfolio containing 44 years of accumulated knowledge in the form of notes, diagrams, and drawings he'd collected from every job he'd ever worked. The security guard at the entrance checked his ID and made a phone call. 2 minutes later, a young man emerged from the building, practically running. Mr. Kaczynski, he extended his hand. Tyler Chun, thank you for coming so quickly. Tyler was maybe 29, 30 at most, wearing jeans, Tesla-branded hoodie, expensive sneakers, the uniform of young tech workers who'd never set foot in a real factory before Tesla made manufacturing cool again. Call me Robert. Show me the problem. Tyler led him through security, through the main building, into the factory floor proper. The noise hit Robert immediately even with one line down. The factory was still operating at massive scale, stamping presses, welding robots, conveyor systems, the metallic smell of hot metal and lubricants, and electrical equipment running at capacity. They walked past the operational lines Model 3, South, and Model X's, being built in choreographed mechanical precision toward the frozen Model Y line at the far end of the facility. A group of people were gathered around one section of the line. Engineers, technicians, managers, all young, all looking exhausted and frustrated. Team, Tyler called out. This is Robert Kaczynski. He's a consultant with 40-plus years of automotive manufacturing experience. He's here to help us troubleshoot. The reaction was immediate and obvious. I scanned Robert from head to toe. Took in his age, his worn work boots, his thermos, his leather portfolio. One of the engineers, A woman who couldn't have been older than 27 exchanged glances with her colleague and smirked. A young man, probably early 30s, beard carefully groomed to look casually stylish, looked at Tyler and said loud enough for everyone to hear, "This is who they sent us. We asked for help, not a retirement home." A few people laughed. Not everyone, but enough. Robert had experienced this before. The casual dismissal, the assumption that age meant incompetence, the mockery disguised as jokes. He said nothing, just looked at the frozen production line, the robot arms frozen mid-motion, the partially assembled Model Y sitting dead on the conveyor belt. "What have you tried so far?" Robert asked, his voice calm and professional. The bearded engineer at his name tag, read Derek, lead production engineer, rolled his eyes. "Everything. We've reset the system. We've checked every sensor. We've reviewed every line of code. We've replaced suspected faulty components. We've had 8 engineers working around the clock for 3 days. Whatever's wrong, it's not something obvious. Have you checked the calibration on the primary assembly robots?" Robert asked. "Of course, we've checked the calibration," Derek said, his tone dripping with condescension. "That's literally the first thing we checked. We're not idiots." "Show me your calibration logs," Robert said. Derek exchanged another look with his colleagues. The expression was clear. "Who is this old guy to question us? I don't have time to walk a consultant through everything we've already done," Derek said. "We need someone who can actually solve this, not someone who's going to ask us to explain everything like we're teaching a class." "Derek," Tyler said, his voice carrying a warning. "What?" "I'm just saying what everyone's thinking. We've been here for 72 hours straight. We're exhausted. And instead of getting someone who understands modern manufacturing, they send us." He gestured vaguely at Robert, a guy who probably learned his trade when robots were science fiction. "I learned my trade," Robert said quietly, "when robots broke down and you couldn't just Google the answer. When you had to actually understand how machines work, instead of assuming the software will fix everything." He set down his thermos and opened his leather portfolio, pulled out a sheaf of papers, actual engineering drawings, schematics, calibration protocols he'd developed over decades. The engineer stared at the papers like Robert had pulled out a stone tablet and chisel. "Are those ... printed diagrams?" The woman who'd smirked earlier asked. "On paper." "Yes," Robert said. "Dude," another engineer said, "it's 2025. We don't use paper. Everything's digital." "And where's your digital documentation right now?" Robert asked. "On tablets that need to be charged. On a network that goes down. Paper doesn't crash. Paper doesn't need Wi-Fi. Paper works when your fancy tech fails." He walked toward the frozen production line, studying the robot arms, the partially assembled vehicle, the positioning of the components. "Which robot is the primary assembly unit?" Robert asked. Tyler pointed. "The big one in the center. That's the main body panel installer." Robert approached it, looked at the positioning, the servo motors, the hydraulic systems. Then he did something that made several of the young engineers gasp. He climbed up onto the platform to get a closer look at the robot arm assembly. "Sir, you can't," one of them started to say. "Their line's down," Robert interrupted, "which means it's not dangerous." "I need to see the calibration markers." He studied the robot arm for about 90 seconds, running his hands along the joints, checking the alignment visually, the way he'd been trained to do before digital sensors existed. Then he climbed back down. "Your problem," Robert said, "is that your primary assembly robot is miscalibrated by approximately 3 millimeters on the horizontal axis. When it tries to place the body panel, it's off position, which triggers the safety sensors and shuts down the entire line. That's impossible, Derek said immediately. We checked the calibration multiple times. The sensors show it's perfectly aligned. Your sensors are wrong, Robert said. The calibration tool you're using is programmed with the wrong baseline parameters. How would you possibly know that Derry demanded? Because I can see it, Robert said simply. The mounting brackets on the robot arm are showing where patterns that indicate the arm has been operating slightly off axis for probably 2 weeks. Your sensors are measuring against a baseline that's drifted. You need to recalibrate using physical measurements, not digital sensors. The group of engineers stared at him. That's ridiculous, Derek said. Our calibration system is it's accurate to within microns. You're telling me you can see a 3 millimeter misalignment with your naked eye? I've been doing this for 44 years, Robert said. Yes, I can see it. This is a waste of time, Derek said, turning to Tyler. We're losing money every second this line is down, and you brought in some old guy who thinks he can eyeball calibration better than our $1 million sensor systems. Tyler looked between Derek and Robert, clearly caught between his expensive young engineers and this old consultant who just made a diagnosis in 90 seconds that contradicted 3 days of sophisticated analysis. Robert, Tyler said carefully, our calibration system cost $1.2 million. It's the same system Boeing uses for aircraft assembly. It's accurate to within microns. Are you absolutely certain it's wrong? Test it, Robert said simply. Get me a laser measuring tool and a calibration template. I'll prove it in 5 minutes. Derek actually laughed out loud. A laser measuring tool? What are you going to do? Manually measure like it's 1985? Yes, Robert said without emotion. That's exactly what I'm going to do, because sometimes the old ways work better than the new ways. Sometimes experience beats technology. This is insane, Derek said, turning to his team. We're wasting time listening to someone who probably learned his trade using slide rules and Derek. Tyler's voice cut through the noise with unexpected authority. Get the measuring tools now? Derek's jaw tightened, but he nodded to one of the other engineers, who jogged off toward the equipment room. The young woman who'd smirked earlier, her name tag read Ava, manufacturing engineer, crossed her arms and said, even if you're right about the calibration, which you're not, fixing a 3 millimeter alignment issue would take hours. We'd have to recalibrate the entire robot assembly system, reset all the parameters, run test cycles. This line won't be running until tomorrow at the earliest. It'll be running in 3 hours, Robert said. 3 hours. Another engineer, an Asian American man in his late 20s, named James, shook his head. That's impossible. Even if we knew exactly what was wrong, the recalibration process alone takes 6 hours minimum. Your recalibration process takes 6 hours, Robert corrected. My recalibration process takes 90 minutes. Your process, Derek said incredulously. You mean some outdated manual process from the 1980s that probably violates every modern safety and quality protocol. I mean a process that actually works, Robert said. The engineer returned with a laser measuring tool and a metal calibration template, a precision machine plate with marked reference points. Robert took them and approached the frozen robot arm again. For the next 3 minutes, he measured, not using the fancy digital calibration system, but manually. Laser measurement from the base to each joint. Comparison against the template at multiple points. Notes scribbled in a small notebook he pulled from his tactual handwritten notes with a mechanical pencil. The young engineers watched with expressions ranging from curiosity to contempt. He's literally writing on paper, someone muttered. Does he know computers exist? Another whispered. Robert ignored them. He'd learned decades ago that the best response to mockery was competence. After 3 minutes and 42 seconds, he straightened up and walked back to the group. Horizontal axis is off by 3.2 millimeters, Robert said. Vertical axis is off by 1.1 millimeters. Rotational axis is off by 0.4 degrees. Your calibration system is measuring these as within tolerance because your baseline parameters are wrong. He held up his notebook, showing his calculations. Derek grabbed it, studied it for a moment, then looked at his own tablet, displaying the digital calibration data. His expression shifted from contempt to confusion. That can't be right, Derek said. But his voice had lost its certainty. Run a manual verification, Robert said. Use the laser measurement system independently of your calibration software. Check the physical positioning against known reference points. You'll see I'm right. Tyler looked at Derek. Do it. For the next 12 minutes, Derek and 2 other engineers performed manual measurements, comparing them against the digital calibration system's readings. Robert stood to the side, sipping coffee from his thermos, watching young people slowly realize that their expensive technology had been lying to them for weeks. At minute 8, Derek's face went pale. "Aci minuciten," Eva said. "Oh my God." Loud enough that several other people looked over. At minute 12, Derek set down his measuring equipment and looked at Robert with an expression that was equal parts shock and humiliation. "You're right," Derek said quietly. "The calibration system has been using corrupted baseline parameters. The robot's been operating off position for ... Coetzee checked his tablet. 17 days. Since the last software update to the calibration system. Which means, Robert said, that someone updated your calibration software without verifying it against physical measurements. So the software started measuring against incorrect baselines, and every calibration check you ran was comparing wrong data against wrong data. The gathered engineers went very quiet. "How did we miss this?" James asked, not to anyone in particular. "Because you trusted the technology," Robert said. "You assumed that $1 million system couldn't be wrong. You assumed that digital was always better than manual. You assumed that old methods were obsolete." He looked directly at Derek. "I learned to do this work before digital calibration systems existed. I learned to use my eyes, my hands, my experience. I learned to trust what I could measure physically more than what a screen told me. That knowledge didn't become obsolete just because new technology came along. It became more valuable because it's the backup for when the technology fails." Derek said nothing. He was staring at his tablet like it had betrayed him. "Can you fix it?" Tyler asked Robert. "Yes. Give me access to your calibration system controls and 90 minutes. I'll have this robot realigned and the line running." "What do you need from us?" Tyler asked. "Tools, access, and for everyone to stay out of my way." For the next 93 minutes, Robert worked not with a team, not collaborating, just him, the robot, and 44 years of accumulated knowledge about how machines actually work when you strip away the fancy software interfaces and get down to physics and mechanics. He recalibrated the robot arm manually, using the laser measurement system and physical reference points. He adjusted the servo motors 1 micron at a time, testing the movement range at each step, feeling the resistance in the hydraulics, the way a doctor might feel for a pulse. The young engineers watched from a distance. Most had gone back to their stations, exhausted from 3 days of failed troubleshooting, but several stayed, observing this old man with his paper notes and mechanical pencil doing work they'd been taught was obsolete. Ava approached after about 45 minutes. "Can I ask you something?" she said. Robert didn't look up from his adjustments. "Sure. How did you see the misalignment? Like, actually see. We had sensors measuring everything. The wear patterns on the mounting brackets, Robert said. See this? He pointed to a subtle discoloration on the metal. That's stress marking. It indicates the bracket has been experiencing force from a slightly wrong angle for an extended period. Your sensors measure position, but they don't look at physical wear. I learned to read wear patterns because that was the only way to diagnose problems before we had fancy sensors. They don't teach that anymore, Ava said quietly. I know, Robert said. That's the problem with modern engineering education. They teach you to use tools without teaching you to understand what the tools are measuring. So, when the tools fail, you're lost. Is that why... ... Double quotes, she hesitated. Is that why you were unemployed? Because you use old methods. Robert looked at her for the first time since she'd approached. I was unemployed because I'm 67 years old and companies think that means I'm obsolete. They see my age and assume I can't learn new things, can't adapt, can't keep up with younger engineers. They don't see the value in experience because they've been told that innovation only comes from youth. But you're fixed in 90 minutes what we couldn't fix in 3 days, Ava said. Yes, Robert said simply, and went back to his calibration work. At the 70-minute mark, Robert ran a test sequence. The robot arm moved through its full range of motion, smooth and precise, placing an imaginary body panel in exact position. Primary calibration complete, Robert announced. Now, I need to recalibrate the secondary robots that interact with this one. They've been compensating for the misalignment, so their positioning is also off. How long will that take? Tyler asked, appearing from wherever he'd been during the calibration work. 35 minutes, Robert said. You're sure the line will run after this? I'm sure, Tyler nodded. I'm calling the production director. He needs to see this. At 11:47 p.m., 3 hours and 11 minutes after Robert had walked into the Gigafactory, the Model Y production line roared back to life. The robot arms moved. The body panel was lifted, positioned, and installed perfectly. The conveyor system advanced. The next stage of assembly began. Within 5 minutes, the line was running at full speed. Model E's moving through the assembly process with the choreographed precision that had made Tesla famous. Robert stood to the side, sipping the last of his coffee, watching the line run the way lines were supposed to run. The production floor erupted in cheers. Engineers who'd been working for 3 days straight, who'd been exhausted and frustrated and convinced they'd never fix the problem, were hugging each other and high-fiving and celebrating like they'd won a championship. Tyler approached Robert, and his eyes were actually wet with emotion. You did it, Tyler said. Holy shit! You actually did it! I told you I would, Robert said. 3 hours and 11 minutes. You said 3 hours. You were off by 11 minutes. I allowed for margin of error, Robert said. The secondary robots were more out of alignment than I initially estimated. A man in his mid-40s approached sharply dressed, carrying himself with the authority of someone used to being in charge. Tyler straightened up immediately. Mr. Matthews, Tyler said, this is Robert Kaczynski, the consultant who fixed the line. Marcus Matthews extended his hand. I'm the production director for this facility. I just watched you restart a line that's been down for 72 hours, costing us approximately $47 million. Tyler tells me you diagnosed the problem in 90 seconds. Approximately, Robert said, shaking his hand. It took me 3.5 minutes to be certain. Marcus smiled. Walk with me. They walked away from the celebrating engineers toward the quieter observation deck, overlooking the main production floor. I want to hire you, Marcus said directly. full-time. Senior Principal Manufacturing Engineer, $210,000 base salary. Stock options, full benefits. I'll have an offer letter drafted tonight. Robert blinked. After 3 years of rejection, after 317 applications and 0 offers, someone was offering him a job. Your team spent 3 days trying to fix that line, Robert said. They're all young, all smart, all educated, at top engineering schools, and they couldn't do what I did in 3 hours. I know, Marcus said. Do you know why? Tell me. Because they've been taught that technology is always right, that digital is always better than manual, that the old ways are obsolete. So when their technology failed them, they had no backup, no foundational knowledge of how to diagnose problems without fancy sensors and software. And you have that knowledge? Marcus said. I have 44 years of that knowledge, and I've been unemployed for 3 years because every company I've applied to decided that knowledge was worthless compared to youth and enthusiasm. Marcus was quiet for a moment, watching the production line below. Did you apply to Tesla? 6 times over the past 2 years, Robert said. Never heard back once. Our automated hiring system filters applications based on various criteria, Marcus said. Age isn't supposed to be one of them, but ... double quotes. He paused. I suspect it is indirectly, through proxies like years since graduation or preferred experience ranges. I know how the systems work, Robert said. I've been filtered out by every major automotive company. Ford, GM, Toyota, Honda, Rivian, Lucid. All of them. They all use the same algorithmic filters that decide I'm too old before a human ever sees my application. That's going to change here, Marcus said. Starting tonight, I'm personally reviewing our hiring protocols, and I'm bringing you in not just as an engineer, but as someone who's going to help me fix a systemic problem. What problem? We've built a culture that worships youth, that assumes innovation only comes from people under 35, that treats experience as a liability instead of an asset. And tonight proved that's wrong. Derek and his team are brilliant engineers, but they don't have the foundational knowledge you have. They can't see what you can see, diagnose what you can diagnose, because they've never had to. Marcus turned to face Robert directly. I want you to teach them. Not formally, not in a classroom, but by working alongside them, by showing them that old methods aren't obsolete, they're foundational, by proving that age and experience are assets, not liabilities. And if they don't want to learn? Robert asked. Derek made it pretty clear he thinks I'm a relic from a bygone era. Derek's about to learn a very important lesson about humility, Marcus said. And if he can't learn it, he won't be working here much longer. Monday morning, Robert Kaczynski walked into the Tesla Gigafactory as an employee for the first time. He'd spent the weekend processing what had happened. The job offer. The salary more than he'd made at the peak of his career at Ford. The health insurance. The stock options that, if Tesla's share price continued climbing, could be worth substantial money. After 3 years of desperation, of watching his savings drain away, of eating rotisserie chicken in parking lots, he had financial security again. But more than that, he had purpose, validation, proof that his 44 years of experience meant something. Tyler met him at security and walked him through the onboarding process. Badge photo, parking pass, computer login, all the mundane administrative tasks that came with starting a new job. Marcus wants you to meet with the production engineering team at 9, Tyler said. There's going to be some tension, because I made Derek look bad Robert said. Because you made Derek's entire approach to engineering look bad, Tyler corrected. He's been here for 4 years. He's considered one of our best young engineers, and you solved in 3 hours what he couldn't solve in 3 days. That's going to be a difficult pill for him to swallow. Is he going to be a problem? Robert asked. Probably, Tyler admitted, but Marcus made it clear. Anyone who can't work with you is welcome to find employment elsewhere. The meeting was in a conference room overlooking the main production floor. Robert arrived at 8:55 a.m., wanting to be early, wanting to make a good impression on his first official day. Derek was already there, along with 5 other engineers from his team. Ava, James, and 3 others Robert hadn't met during the crisis. They were all sitting on one side of the conference table, a united front. Robert sat on the opposite side. The body language was clear. This was Us. Marcus arrived at 9:02 a.m. with Tyler. They sat at the head of the table. Good morning, Marcus began. I want to start by addressing what happened this weekend. Our Model Y line was down for 72 hours. We tried everything we knew to fix it. We failed. Robert Kaczynski, a consultant with 44 years of automotive manufacturing experience, diagnosed the problem in under 4 minutes and had the line running in just over 3 hours. Derek stared at the table. This exposed a significant gap in our engineering team's capabilities. Marcus continued. Not a gap in intelligence or education, you're all brilliant engineers, but a gap in foundational knowledge, in the ability to diagnose problems without relying entirely on digital systems and automated tools. Robert is joining us full-time as our new senior principal manufacturing engineer. His role will be to work on our most complex manufacturing challenges, to review critical systems for potential issues, and most importantly, to mentor our engineering team in the fundamentals of manufacturing that don't get taught in modern engineering programs. Ava raised her hand. So, he's going to be like our supervisor? No, Marcus said. He reports directly to me, same as Derek. You'll be working as peers. The tension in the room was thick enough to cut. I have a question, Derek said, looking directly at Marcus rather than at Robert. No disrespect intended to Robert, but if we're going to be working together as peers, I need to understand his qualifications. What modern manufacturing systems is he certified in? What CAD software does he use? What programming languages does he know? It was a trap question. Derek knew the answer. I'm certified in SolidWorks and AutoCAD from about 15 years ago, Robert said calmly. I've used various CAD programs over my career, though I'm not current on the latest versions. I know basic programming enough to write scripts for automation systems, but I'm not a software engineer. So you don't know Python? Derek asked. Or any of the modern manufacturing programming languages we use here? No, Robert admitted. And you're not familiar with our digital twin simulation systems, our AI-driven predictive maintenance tools, our IoT sensor networks? I can learn them, Robert said. But no, I'm not familiar with those specific systems. Derek looked at Marcus. Then I don't understand how someone who doesn't know our tools, our systems, or our programming languages is supposed to be our peer. It would be like hiring someone who doesn't speak English to teach an English class. Derek, Marcus said, his voice carrying a warning edge. I'm not trying to be difficult, Derek said, though he absolutely was. I'm trying to understand the logic. We're a cutting-edge manufacturing facility using the most advanced robotics and automation systems in the world. And we're hiring someone whose experience is in what? Ford factories from the 1980s. My experience, Robert said quietly, is in understanding how machines actually work, how materials behave under stress, how to diagnose problems by looking at physical evidence instead of just reading sensor data, how to fix things when your fancy software fails. But our software doesn't fail, Derek said. Or it's not supposed to. And when it does, we have IT specialists who handle that. Your software failed this weekend, Robert pointed out. Your $1 million calibration system was giving you false readings for 17 days, and none of you caught it because you trusted the technology more than your own observations. That was one incident. Derek started. How many other systems are failing right now without you knowing? Robert interrupted. How many other sensors are drifting? How many other calibrations are off? You can't see what you're not looking for. And you're not looking because you assume the technology will tell you. The room went silent. This is exactly why I hired Robert, Marcus said. Because we've become too reliant on technology. We've built an engineering culture that treats digital tools as and when those tools fail, not if, but when we don't have the foundational knowledge to fall back on. So we're supposed to go backward? Derek asked. Start using slide rules and paper blueprints. You're supposed to understand what your tools are actually measuring, Robert said. You're supposed to be able to verify digital data against physical reality. You're supposed to have backup methods when your primary methods fail. That's literally what we tried to do this weekend, James interjected. We tried everything. Multiple approaches, multiple tools. You tried digital approaches, Robert Guru. Software resets, code reviews, sensor replacement. You never once got down on the floor and physically looked at the machines with your own eyes. You never manually measured anything. You never checked for physical evidence of problems. Because we're not mechanics, Ava said. We're engineers. We design systems. We don't crawl around on factory floors. Then you're not engineers, Robert said bluntly. You're programmers who happen to work in manufacturing. Real engineers understand the physical systems they're designing, not just the software that controls them. The tension spiked. Several of the younger engineers looked offended. I think we should take a break, Marcus said, sensing the meeting was about to spiral. Robert, can you stay for a moment? The other engineers filed out, Derek shooting Robert a look that was pure hostility. When they were alone, Marcus sighed. That went about as badly as I expected. They think I'm a relic, Robert said. They think my knowledge is obsolete, and I'm just here because you're feeling nostalgic for the old days of manufacturing. What do you think? Marcus asked. I think they're brilliant kids who've never been taught the basics. They can write code and run simulations, but they can't look at a machine and see what's wrong with it. They're like surgeons who can read MRI scans but can't perform a physical exam. Can you teach them? I can try, Robert said, but they have to want to learn. And right now, they don't. They see me as a threat, not a resource. Give it time, Marcus said. You saved us $47 million and potentially our entire production schedule. The team might not like you yet, but they'll respect you eventually. The culture clash between Robert and the young engineering team came to a head 2 weeks later. Robert had been spending his time doing what Marcus had hired him to do, reviewing critical systems, checking calibrations manually, looking for potential problems before they became disasters. He'd already found 3 issues that the automated monitoring systems had met, problems that would have become major problems if left unaddressed. But the young engineers saw his work differently. They saw him as someone who didn't trust their systems, who was constantly second-guessing their work, who represented a past they'd been taught to move beyond. The breaking point came during a design review meeting for a new assembly robot that Derek's team had been developing. The robot was designed to install the Model Y's rear suspension system, a complex task requiring precise positioning and torque control. Derek's team had been working on it for 6 months, and they were ready to deploy it to the production line. Robert had been asked to review the design as part of his role overseeing critical systems. The meeting was attended by Derek's entire team, plus Marcus and Tyler. Derek presented the design with obvious pride, detailed CAD renderings, simulation results, performance predictions. "We've run this through over 10,000 simulation cycles," Derek explained. "The AI optimization system has fine-tuned every movement parameter. We're projecting a 12% improvement in assembly time and a 7% reduction in error rate compared to the current manual process." The presentation was impressive, sophisticated, exactly what you'd expect from a team of talented engineers with access to cutting-edge tools. Then Marcus asked, "Robert, thoughts?" Robert had been studying the design specs on his tablet, taking notes in his leather-bound notebook. He looked up. "The design won't work," he said simply. The room went silent. "Excuse me," Derek said, his voice tight. "The suspension mounting points on the Model Y chassis have a tolerance variance of plus 2.3 millimeters due to thermal expansion in the metal during the welding process," Robert said. "Your robot is programmed with fixed positioning parameters that don't account for that variance. So about 1 in every 7 vehicles will have mounting points slightly out of position, and your robot will either fail to install the suspension properly or will force it into place with incorrect torque, creating stress points that will lead to premature failure." Derek stared at him. "That's not possible. We've run 10,000 simulations." "Did your simulations account for thermal expansion in the chassis metal?" Robert asked. "The chassis is within spec," Derek said. "We used the CAD specifications provided by the design team." "CAD specifications show ideal dimensions," Robert said. "Real-world manufacturing introduces variance. The Model Y chassis, specifically the rear section where your robot will be working, goes through a welding process that heats the metal to approximately 1,400 degrees Celsius. That causes the metal to expand, then contract as it cools. The cooling doesn't happen uniformly, which means the final dimensions vary slightly from the CAD specifications by 2.3 millimeters. James asked skeptically. "That seems high." "Measure it," Robert said. "Take 10 random Model Y chassis coming off the welding line and physically measure the suspension mounting points. You'll find variance of between 1.8 and 2.7 millimeters depending on ambient temperature, cooling time, and metal composition vary." "We don't need to measure it," Derek said. "Our quality control systems already check those dimensions. If there were variances outside of spec, they'd be flagged. Your quality control systems check whether the chassis is within acceptable tolerance," Robert said. "But your robot isn't programmed to work within that tolerance range. It's programmed with fixed parameters that assume every chassis is identical to the CAD spec." Derek's jaw tightened. "You're saying 6 months of work is worthless?" "I'm saying your robot needs adaptive positioning," Robert said. "You need to add sensors that measure the actual mounting point locations on each individual chassis and adjust the robot's movements accordingly. Otherwise, you're going to have a significant failure rate that would require completely redesigning the control system," Ava said. "That's weeks of additional work." "Better to spend weeks now than to deploy a system that fails," Robert said. Derry looked at Marcus. "With respect, Robert is making assumptions based on theoretical concerns. We've simulated this extensively. The design is sound. Have you tested it on actual chassis? Robert asked. We've run bench tests with sample chassis, Derek said. How many? 3. 3 chassis. Probably all from the same production batch. Probably measured under controlled conditions, Robert said. That's not representative of real-world variance. You don't know that, Derek said, frustration clear in his voice. I've been doing this for 44 years, Robert said. I've seen this exact problem destroy 3 different assembly robot deployments at Ford. Same issue. Fixed positioning parameters that don't account for manufacturing variance. Every time, the engineers insisted the simulations showed it would work. Every time, it failed in production. This isn't Ford, Derek said. Our manufacturing processes are more precise. Test it, Robert interrupted. Take your robot. Run it on 20 random chassis straight from the production line and see what happens. If I'm wrong, I'll apologize publicly. If I'm right, you add adaptive sensors. Derek looked at Marcus. This is going to delay our deployment by at least a month. Do the test, Marcus said. 3 days later, the results came back. Derek's robot had been tested on 20 randomly selected Model Y chassis. 7 had mounting points outside the robot's tolerance range. 4 of those 7 resulted in failed installations. 2 resulted in installations that appeared successful but had incorrect torque, values that would likely lead to premature suspension failure. Exactly as Robert had predicted, the meeting to discuss the results was tense. Derek looked like he hadn't slept. His team looked embarrassed and frustrated. Robert was right, Marcus said, breaking the uncomfortable silence. The robot needs adaptive positioning sensors. Derek, how long will that take to implement? 4 weeks, minimum, Derek said, not looking at Robert. Complete redesign of the control system, new sensor integration, extensive testing. 4 weeks is acceptable, Marcus said, but I want Robert involved in the redesign. He doesn't know our programming systems, Derek said. Then teach him, Marcus said, and learn from him. He knew this would fail because he's seen it before. That's the value of experience. After the meeting, Robert found himself alone in the conference room with Derek. You made me look like an idiot, Derek said. I saved you from deploying a system that would have failed in production. Robert cried. That's not making you look like an idiot. That's doing my job. Your job is to review systems, not to undermine my team's work, Derek said. Your work was going to fail, Robert said bluntly. If I'd said nothing and let you deploy that robot, you would have spent 4 months troubleshooting production failures before figuring out the problem. I gave you the answer in 5 minutes during a design review. That should make your job easier, not harder. It makes me look incompetent, Derek said. I spent 6 months on that design. I ran 10,000 simulations, and you saw a problem I missed by just looking at the specs for 5 minutes. I didn't miss it because I'm smarter than you, Robert said. I saw it because I've made that exact mistake before at Ford. In 1997, we deployed an assembly robot with fixed positioning 4-door panel installation. Same problem, manufacturing variance in the body panels meant the robot couldn't adapt. It took us 3 months and $2 million to fix it. I learned that lesson. Now, I'm trying to save you from learning it the same expensive way. Derek was quiet for a moment. How many of these lessons do you have? Hundreds, Robert said. Thousands. Maybe. Every mistake I've made, every problem I've solved, every failure I've witnessed, they're all filed away in my head. That's what 44 years of experience means. It's Not that I'm smarter or better. It's that I've already seen most of the ways things can go wrong. And you think we're arrogant because we haven't seen those things? Derek said. I think you're confident in your tools without understanding their limitations, Robert said. Simulations are incredibly useful, but they're only as good as the assumptions you program into them. If you don't account for manufacturer invariance because you assume everything will be perfect, your simulation will tell you something will work when it won't. Derek nodded slowly. I still don't like you. That's fine, Robert said. You don't have to like me. You just have to be willing to learn from me. Because Marcus is retired, not here to replace you or undermine you. I'm here to teach you the things they don't teach in engineering school anymore. That evening, Robert sat in his apartment still. The same small studio in Sparks, though now he could afford to move somewhere better and did something he hadn't done in 3 years. He opened the box. It was a simple cardboard box, worn at the corners, with Margaret's things written in his handwriting on the side. He'd packed it 3 years ago, 6 months after the cancer took her, when he'd finally accepted that she wasn't coming back and he needed to sort through her belongings. Most of her things he'd donated or given to their daughter Claire, but some items stood ones that hurt too much to look at, but that he couldn't bear to part with had gone in this box. And the box had stayed sealed in the back of his closet ever since. Now, sitting on his second-hand couch with a beer he'd bought because he could finally afford beer again, Robert opened it. The thermos was in there, the one Margaret had given him for his 45th birthday. For the engineer who never stops working, Descartes had said. He'd been using it every day since she died, filling it with coffee every morning, carrying it like a talisman. There was a photo, Margaret at their daughter's college graduation, smiling so wide her eyes disappeared, proud beyond measure. That was before the diagnosis, before the word cancer had entered their vocabulary and changed everything. There was a notebook she'd kept during her treatments. Dates, medications, side effects, questions for doctors, prayers scribbled in the margins. Robert had found it after she died and had read through it once, crying so hard he thought he'd break apart. He hadn't looked at it since. And there were bills, medical bills, the physical manifestation of the American healthcare system's brutality. $47,000 for the first round of chemotherapy, $89,000 for the surgery that was supposed to remove the tumor but found that it had already spread, $134,000 for the experimental treatment that gave them 6 more months, but ultimately didn't work. Insurance had covered some of it. Not enough. Never enough. Robert had paid what he could from their savings. Then from his retirement account's early withdrawal, penalties, taxes, watching 40 years of careful planning evaporate. Then from the equity in their house. Then from loans he'd taken against his pension. By the time Margaret died, they had $27,000 left to their names and $156,000 in remaining medical debt. And then Ford had forced him into early retirement 6 months later. Robert had tried to negotiate, tasked. If he could stay on, explained his situation, begged for just a few more years to rebuild his savings. We're restructuring, they'd told him. This is a business decision, not personal. Everything is personal when it destroys your life, Robert thought. He'd taken the severance package because he had no choice. Used most of it to pay down the medical debt. Got it down to $68,000, which was still crushing, but at least manageable. Moved from Michigan to Nevada because the cost of living was lower and he needed to stretch every dollar. And then he'd discovered that nobody wanted to hire a 64-year-old engineer who'd worked for one company his entire career. Overqualified, not a good fit, looking for someone who can grow with the company. Translation, you're old, you're expensive, and you'll probably die before you can justify our investment in hiring you." For 3 years, Robert had watched his savings shrink month by month, watched his remaining retirement accounts dwindle as he was forced to take early distributions just to pay rent and buy food, watched the medical debt grow as interests compounded. He'd been 3 months away from bankruptcy when Tyler called him about the Tesla emergency. 3 months away from losing everything Margaret and he had built together over 43 years of marriage. 3 months away from becoming one of those statistics you read about. Elderly Americans living in their cars because they couldn't afford housing on Social Security alone. And now, sitting in his small apartment with Margaret's things spread around him and a job offer that paid $210,000 a year, Robert felt something he hadn't felt in 3 years. Hope. Not just hope for himself. Hope that maybe the system wasn't completely broken. Hope that maybe experience and wisdom still mattered in a world that seemed to worship only youth and novelty. Hope that maybe he could rebuild what had been taken from him. He pulled out his phone and called his daughter. Claire answered on the second ring. "Dad, is everything okay?" "Everything's fine," Robert said. "Better than fine. I have news. Good news or bad news? Good news. Great news. Actually, I got a job." There was a pause. Then, a real job. Not consulting. A real job. Full-time. Tesla. Senior Principal Manufacturing Engineer. Tesla. Claire's voice went up an octave. The Tesla. The car company. The car company. "Dad, that's amazing." "How much does it pay?" Robert told her. He heard her gasp. "That's more than you made at Ford," she said. "I know. Dad, you can pay off Mom's medical bills. You can rebuild your retirement. You can actually live instead of just surviving." "I can," Robert said. "I know you've been struggling since Jake left too." Claire had divorced 2 years ago, left with 2 kids and minimal child support from an ex-husband who decided being a father was too much responsibility. She was working as a teacher, barely making ends meet. "Dad, you don't have to. I want to," Robert interrupted. "Your mother would have wanted me to. She worried about you constantly, especially toward the end. She made me promise I'd take care of you and the kids if anything happened to her. I'm not a kid anymore," Claire said, but her voice was thick with emotion. "You're always going to be my kid," Robert said. "And now I can finally keep the promise I made to your mother." They talked for another 20 minutes. Claire cried happy tears this time, not the worry tears Robert had heard too often over the past 3 years. She told him about his grandkids, about school, about the small apartment she was renting that was too small but was all she could afford. "Come visit me," Robert said. "Once I get settled, bring the kids. We'll go see the Gigafactory. Let them see where Grandpa works. They'll think it's cool." "They will," Claire agreed. "And Dad, I'm proud of you for not giving up. I know the past 3 years have been. I know it's been hard. Harder than anything except losing your mother," Robert said. "But I made it through. We made it through." After they hung up, Robert carefully packed Margaret's things back into the box. But he kept the photo out to one of her at Claire's graduation. He put it on his small desk where he could see it every day. "I kept my promise," he said to the photo. "It took longer than I thought. I almost didn't make it, but I kept my promise." Over the next 3 months, something remarkable happened at the Tesla Gig. The young engineers Derek's team slowly, grudgingly, began to respect Robert. It started with small things. Eva asking Robert to review a design before submitting it for approval. James seeking Robert's advice on a calibration issue he was struggling with. Even Derek still proud and defensive, occasionally running ideas past Robert before committing to them. Robert didn't lord his knowledge over them, didn't make them feel stupid for not knowing what he knew. He taught the way Margaret had taught when she'd been a high school teacher before the cancer, with patience, with respect for the learner, with the understanding that everyone starts somewhere. "This is how I learned to read wear patterns," he'd say, showing them the subtle discolorations and stress marks on mechanical components that indicated developing problems. "This is what thermal expansion looks like in real manufacturing, not in simulations. This is why you can't trust sensors without verifying them against physical measurements." And slowly they learned. Derek learned to check calibrations manually in addition to digitally. Ava learned to look at physical evidence before trusting sensor data. James learned that simulations were tools, not prophecies, useful but fallible. The culture began to shift. The engineers started talking about old-school verification as a valuable skill set rather than outdated methodology. They started asking Robert to teach them things: how to read technical drawings from before CAD, how to diagnose problems without sophisticated sensors, how to think through complex mechanical systems without relying on software. And Robert, for the first time in 3 years, felt valuable again. Not just employed, but genuinely useful, making a difference, teaching the next generation instead of being discarded by them. But the real transformation came during the Model X crisis. It was a Tuesday in February, 4 months after Robert had started at Tesla. The Model X production, the one producing Tesla's luxury SUV, started showing intermittent quality issues. Nothing catastrophic, but concerning: door panel alignment slightly off, window seals not quite flush, interior trim pieces with minor gaps. Quality control was catching the issues before vehicles shipped, but the rework was costing time and money, and nobody could figure out why it was happening. The issues had started 3 weeks ago. Their team had been troubleshooting for 2 weeks. They'd checked every robot, every calibration, every piece of software. Everything looked perfect in the digital systems, but the physical vehicles kept showing defects. Marcus called Robert into a meeting with Derek's team. "We're bleeding about $200,000 a week in rework costs. It's not catastrophic, but it's not sustainable." Ideas. Derek had walked through everything they'd checked. Robot calibrations, perfect. Software parameters correct. Sensor readings, all within tolerance. Material specifications, meeting requirements. "Everything looks right," Derek said, frustrated. "But the vehicles are still coming out wrong." "When did the issues start?" Robert asked. 3 weeks ago, Tuesday morning, first shift." "Did anything change in the facility that day?" "New equipment, new procedures, schedule changes." Derek pulled up his tablet. "No. Production schedule was normal. No equipment changes. No software updates. Nothing unusual." "Weather?" Robert asked. Everyone looked at him. "Weather," Derek repeated. "What does weather have to do with it?" 3 weeks ago was when we had that cold snap," Robert said. "Temperatures dropped from 55 degrees to 25 degrees overnight." "Did the factory temperature change?" "The factory is climate controlled," Ava said. "It's always 68 degrees. The main production floor is climate controlled." Robert corrected. "What about the part storage area where you keep the door panels and trim pieces before assembly?" Derek's expression changed. "The part storage area isn't climate controlled. It's just covered, not heated. So when the temperature outside dropped 30 degrees, the temperature in your part storage area also dropped," Robert said. "Which means the metal and plastic components stored there contracted. Not mucha few millimeters at most, but enough to affect fit and alignment when they're installed. That's ... Double quotes James started. Is that possible? It's physics, Robert said. Metal and plastic expand when heated, contract when cooled. You're bringing cold components from storage into a warm factory, installing them on warm vehicles. The fit is fine when you install them, but as the components warm up to ambient temperature, they expand slightly and create the alignment issues you're seeing. The room was silent. How do we fix it? Marcus asked. Climate control the parts storage area, Robert said. Or bring components into the factory 12 hours before installation so they have time to reach ambient temperature before assembly. That simple? Derek asked, disbelief in his voice. That's simple, Robert confirmed. It's a problem I saw at Ford in 2003. We had panel alignment issues every winter until someone figured out it was thermal expansion. Same solution then? Let the parts warm up before installation. They implemented Robert's solution the next day. Parts were moved into the heated factory 12 hours before installation. The quality issues disappeared immediately. Derek came to Robert's office that afternoon. I owe you an apology, Derek said. Actually, I owe you about 50 apologies. Robert looked up from his computer. What for? For being an arrogant ass when you first got here. For mocking your paper drawings and your thermos and your manual measurement methods. For assuming that because you're older, your knowledge was obsolete. For treating you like you were some kind of relic, instead of someone who could actually teach me things. You're young, Robert said. Young people are supposed to be confident and think they know everything. That's normal. That doesn't make it okay, Derek said. You've saved us millions of dollars in the 4 months you've been here. The calibration issue, the suspension robot redesign, now the thermal expansion problem. 3 major problems that we couldn't solve and you solved immediately because you'd seen them before. That's what experience is, Robert said. It's not magic or genius. It's just having lived long enough to see the same problems repeat themselves. Derek sat down. Can I ask you something personal? Sure. How old were you when Ford forced you out? 64. And you applied to how many jobs before Tesla hired you? 317. Derek's eyes widened. 317 applications. Over 3 years. Most never responded. Some sent automated rejections. A handful interviewed me and decided I was too old, too expensive, too something. Tesla was the first company that actually gave me a chance. Why didn't you just retire? Derek asked. You'd already had a full career. You could have just stopped working. Because my wife got cancer and the medical bills destroyed our savings, Robert said bluntly. Because early retirement from Ford came with a pension that wasn't enough to live on. Because Social Security alone doesn't cover rent and health insurance and food. Because I was 3 months away from bankruptcy when Tyler called me about the production line emergency. Derek looked stunned. I didn't know that. Most people don't, Robert said. They see older workers and assume we're working because we're bored or we want extra vacation money. They don't see that many of us are working because the alternative is poverty, because retirement is a luxury that requires savings. And a lot of us don't have savings because medical emergencies or recessions or corporate restructurings wiped us out. I'm sorry, Derek said quietly. Don't be sorry, Robert said. Just learn from it. When you're my age, and you will be someday, faster than you think. Remember what it felt like to be young and confident and convinced you knew everything. And remember how wrong you were. And don't treat the next generation the way yours treated mine. Derek nodded. Deal. 6 months after Robert started at Tesla, Marcus called him into his office. "We need to talk about your role here," Marcus began. Robert's stomach tightened. This was it. They were letting him go. He'd been too expensive, too challenging, too much of a reminder that age mattered in ways that made young people uncomfortable. "Okay," Robert said carefully. "You've been here 6 months," Marcus continued. "In that time, you've identified and solved for major manufacturing problems that our engineering team couldn't solve. You've prevented at least 3 other problems from ever occurring by catching them in design review. You've mentored our young engineers and taught them skills they didn't learn in school. And you've saved this facility approximately $8.3 million in costs." Robert waited for the but. It didn't come. "I'm creating a new position," Marcus said, "Director of Manufacturing Excellence. It's a senior leadership role that reports directly to me. Your job would be to do what you've been doing: review critical systems, mentor engineers, catch problems before they become disasters, but at a higher level, overseeing all production lines, not just Model Y and Model X, working with our other facilities beyond Sparks, helping shape Tesla's manufacturing strategy globally." "What's the compensation?" Robert asked, his mind racing. $275,000 base salary, expanded stock options, full executive benefits package. Plus, you'd have a team 2 or 3 experienced engineers who'd work under your direction. Robert stared at him. "You want to promote me. I want to expand your role so you can have more impact," Marcus clarified. "You've proven that experience and wisdom are assets Tesla desperately needs. I want to scale that across the organization." "What about Derek and his team?" "Derek's been promoted to Senior Production Engineering Manager. He's excellent at his job, but he's learned mostly from you that engineering isn't just about technology. It's about understanding systems at a fundamental level. He'll be working closely with you in your new role." Robert thought about it for exactly 3 seconds. "I accept." "Good. You start in the new role January 1st. That gives us 2 months to structure your team and define responsibilities. But there's one more thing." "What?" "I want you to speak at our annual company meeting in March. Tell your story. How you were unemployed for 3 years, how every company rejected you, how you saved our production line in 3 hours. I want every Tesla employee to understand why we value experience, why age discrimination is not just wrong but stupid, why diversity includes age diversity." "That's going to make people uncomfortable," Robert said. "Good," Marcus replied. "They should be uncomfortable because we almost didn't hire you. If Tyler hadn't called you in desperation, if you hadn't fixed that line, you'd still be applying 2 jobs and getting rejected. And we'd have lost millions of dollars because we were too arrogant to see the value in someone who didn't fit our demographic preferences." The Tesla annual company meeting was held in March at the Gigafactory. Over 1,200 employees attended, including remote workers joining via video conference from other facilities. Robert stood backstage, more nervous than he'd been since his wedding day 45 years ago. Public speaking wasn't his strength. He was an engineer, more comfortable with machines than with audiences. But Marcus had been insistent. "They need to hear this from you. Not from me explaining it, but from you living it." Derek found him backstage. "You nervous?" "Terrified," Robert admitted. "Good," Derek said. "That means you care. You're going to do great." "How do you know?" "Because you're not trying to impress anyone. You're just telling the truth, and truth is always powerful." Marcus introduced him simply. Robert Kaczynski joined Tesla 7 months ago. In that time, he's saved us approximately $11 million, mentored dozens of engineers, and fundamentally changed how we think about manufacturing. I've asked him to share his story. Robert walked onto the stage to polite applause. Looked out at you 1,200 mostly young faces took a breath. My name is Robert Kuczynski. I'm 67 years old. 7 months ago, I was unemployed, nearly bankrupt, and eating rotisserie chicken in a Walmart parking lot because I couldn't afford to fix the stove in my apartment. The room went completely silent. I'd been unemployed for 3 years. I'd applied to 317 jobs. I'd gotten 23 interviews. 0 offers. I have 44 years of automotive manufacturing experience, but nobody wanted to hire me because I'm old. Robert clicked to the first slide of his presentation, his job search spreadsheet showing all 317 applications and rejections. This is what age discrimination looks like. It's not dramatic, it's not violent. It's just being erased. Being told over and over that your experience doesn't matter. Your knowledge is obsolete. You're too expensive. You're not a cultural fit. You're not what companies are looking for. I applied to Tesla 6 times over 2 years. Never heard back once. Your automated hiring system filtered me out before a human ever saw my application. Some people in the audience looked uncomfortable. Good. And then Tyler called me at 2:30 in the morning because your Model Y line had been down for 72 hours and you were about to lose $47 million. I came in. I diagnosed the problem in under 4 minutes. I fixed it in just over 3 hours. And suddenly, I was worth hiring. Click. Next slide. The calibration error he'd found with before and after measurements. I didn't do anything magical that night. I just used knowledge that accumulated over 4 decades. I knew to look at physical wear patterns instead of trusting digital sensors. I knew that calibration systems can drift and need to be verified manually. I knew that sometimes the old methods work better than the new methods. And I knew all of this because I'm old. Because I've been doing this work since before most of you were born. Because I've made every possible mistake and learned from it. Click next slide. Photos of the various problems he'd solved over the past 7 months. In 7 months here, I've saved Tesla approximately $11 million by catching problems that your young, brilliant, highly educated engineers couldn't catch. Not because I'm smarter than them, I'm not, but because I've seen these problems before. Because experience is worth something. Robert paused, looking out at the audience. Here's what I want you to understand. Age discrimination isn't just morally wrong, it's economically stupid. When you reject qualified candidates because they're over 40 or 50 or 60, you're throwing away decades of accumulated knowledge. You're forcing yourself to relearn lessons that have already been learned. You're making expensive mistakes that could have been prevented. When Derek's team spent 3 days trying to fix the production line and failed, that wasn't because they're bad engineers. They're excellent engineers, but they'd never seen that particular problem before. I had. That's the value of experience. Click. Next slide. A photo of Margaret. This is my late wife, Margaret. She died 3 years ago from cancer. The medical bills destroyed our savings. My former employer forced me into early retirement 6 months later. And for 3 years, I couldn't find work because companies looked at my age and decided I was worthless. I was 3 months away from bankruptcy when Tesla gave me a chance. 3 months away from losing everything Margaret and I built together over 43 years of marriage. 3 months away from becoming another statistic, another elderly American living in poverty. Because the system decided we were obsolete. Robert's voice cracked slightly. He took a breath, steadied himself. Age. Discrimination kills people. Maybe not directly, but it destroys lives. It takes people who've worked their entire lives, who've contributed to society, who have valuable knowledge, and tells them they're worthless. It forces them into poverty. It steals their dignity. Tesla gave me my dignity back. Marcus and Tyre and eventually Derek and his team, they saw past my age and recognized my value. And because of that, I'm not just surviving anymore. I'm thriving. I can help my daughter who's struggling as a single mother. I can pay off my wife's medical bills. I can rebuild what was taken from me. But more importantly, I can teach. I can share what I've learned. I can help younger engineers become better engineers by showing them things they weren't taught in school. I can prevent future disasters by catching problems early. I can make Tesla better. Click. Final slides. Just text. Experience doesn't expire. Wisdom doesn't have an age limit. Value doesn't decrease with time. Judge people on competence, not birth date. Thank you for giving me a chance when no one else would. Thank you for being willing to learn that old doesn't mean obsolete. Thank you for proving that a company can be innovative and value experience at the same time. Robert stepped back from the podium. For a moment, silence. Then someone started clapping. Then someone else. Then the entire room was on their feet, applauding, some people crying, many looking at Robert with newfound respect and understanding. Derek was applauding the loudest. Marcus walked onto the stage and shook Robert's hand. That, he said into the microphone, is why we're implementing company-wide changes to our hiring practices. No more age-based filtering. No more discriminatory proxies. We're going to build a team that values diversity of experience, not just diversity of demographic categories. The applause continued. 2 years after Robert walked into the Tesla Gigafactory for the first time, he stood on the same factory floor with a very different perspective. He was now Vice President of Manufacturing Excellence, overseeing production quality across all Tesla facilities globally. His team had grown to 35 people, ranging in age from 24 to 71. They'd implemented standardized verification protocols combining cutting-edge technology with old-school physical inspection methods. Tesla's manufacturing defect rate had dropped by 43%. Production efficiency was up 27%. Employee retention in the engineering departments was at an all-time high because younger engineers were learning from experienced mentors instead of being thrown into positions they weren't prepared for. And Tesla had become known in the industry as the company that valued age, that actively recruited experienced engineers who'd been rejected elsewhere, that proved innovation didn't require youth, it required diverse perspectives. Robert had been profiled in Automotive News, Manufacturing Today, and AARP, the magazine. He'd spoken at 3 industry conferences about age discrimination and the business case for hiring experienced workers. He'd consulted with 6 other automotive companies looking to implement similar practices. And he'd helped change the conversation in the industry from why would we hire someone that old to why wouldn't we want someone with that much experience? But the moment he was proudest of came on a Tuesday in November. Derek, now Director of Production Engine, came to Robert's office with a young woman. Robert, this is my grandmother, Patricia. She's 63. She just got laid off from GM after 38 years as a quality control engineer. I told her Tesla would be interested in talking to her. Robert stood and shook Patricia's hand, saw the same desperate hope in her eyes that he'd carried for 3 years, the same fear that she was too old, too expensive, too obsolete. Welcome to Tesla, Robert said warmly. Tell me about your experience. As Patricia began describing her background, decades of expertise in quality systems, in defect analysis, in manufacturing processes, Robert thought about his own journey. from eating rotisserie chicken in a Walmart parking lot to sitting in a vice president's office, helping another older worker get the chance they deserved. From unemployment and desperation to purpose and dignity. From being told he was worthless to proving he was invaluable. He'd kept his promise to Margaret. He'd taken care of their daughter. He'd rebuilt their finances. He'd survived. But more than that, he'd changed things. One company, one conversation, one hire at a time. Age discrimination still existed. It probably always would, at least partially. The worship of youth was too deeply embedded in American culture to disappear overnight, but it was being challenged, questioned, pushed back against. And Robert Kaczynski, 69 years old, formerly unemployed, formerly told he was too old to matter, was leading that charge. Not because he was special, not because he was a hero, but because he'd refused to accept that his value expired with his youth, because he'd kept fighting when others would have given up, because he'd proven over and over that experience, wisdom, and competence don't have age limits. The young engineers at Tesla no longer mocked paper blueprints or manual measurements. They'd learned that old methods weren't obsolete, they were foundational. They'd learned that innovation required both fresh perspectives and seasoned judgment. They'd learned that age was just a number, and competence was forever. And Robert had learned something too, that survival wasn't just about making it through each day. It was about making those days mean something, about using your hard-won knowledge to help others, about refusing to let a broken system define your worth. As Patricia left his office with a job offer and tears of relief in her eyes, Derek lingered. "You changed my life," Derek said. "You know that, right?" "I fixed a production line," Robert said. "You did more than that," Derek said. "You taught me that being smart isn't the same as being wise, that confidence isn't the same as competence, that the best engineers are the ones who know what they don't know and are willing to learn from anyone, regardless of age." "Your grandmother taught you that," Robert said. "I just reminded you." Derek smiled. "She's going to love working here, and she's going to love working with you." After Derek left, Robert sat alone in his office for a moment, looked at the photo of Margaret on his desk, still there, still watching over him. "We made it," he said to the photo. "It took longer than I thought. It was harder than I imagined. But we made it." The photo didn't answer. Of course, but Robert imagined what Margaret would say. She'd tell him she was proud. She'd tell him that 44 years of experience was worth something. She'd tell him that age was just a number and competence was forever. And she'd be right, because Robert Kaczynski, 69 years old, had proven it.